going to be solving for the force. We're going to be solving for something else. So let's read this one and see how well you can do. Two vinyl balloons with an identical charge are given a separation distance of 52 centimeters. The balloons experience a repulsive force of 2.74 times 10 to the negative third newtons. Determine the magnitude of charge on each one of the balloons. So now I haven't been given the value for the charge. I need to figure that out. Some hints here that you need to make sure that you're aware of. The repulsive force. What does that mean? It means that it matches this right here. Identical charge means they're also going to have the same sign. That is, both charges are positive or both charges are negative. Okay? All right, so let's identify what we know. We know this distance of 52 centimeters. So what are we going to do with that? Okay, that's our D value. And let's just go ahead and convert it because it's given in centimeters. So we're going to convert that to 0.52 meters. And then this number down here, 2.74 times 10 to the negative 3 newtons, that is our force. Okay, so the setup is a little bit different here. We're going to be solving for Q1 and Q2, but knowing that they are equal. Okay, so I'm going to start with my force. So 2.74 times 10 to the negative 3 newtons equals, I cannot forget my K value, so that is 9 times 10 to the ninth Newton meters squared per Coulomb squared times Q1 that I don't know times Q2 that I don't know over my distance squared, which is 0.52 meters squared. Okay, so this one's a little bit tricky. I have to isolate Q1 and Q2. And before we do that, I want you to recognize that if it's the same charge, Q1 and Q2, then I can actually replace this with Q times Q, and that would be Q squared. Okay? Just like our distance squared on the bottom is D times D. Okay, it's not 2 times Q because that would mean we're adding the charges. So just make sure you can recognize this as Q times Q. Just like X times X equals X squared, Q times Q would be Q squared. Okay, that's going to simplify finding the answer for us just a little bit. Okay, so step 1. What are we going to do in step 1? If we have to isolate this Q squared, we need to get rid of what's on bottom. So how do we do that? We multiply it on both sides. It cancels out over here. So I'm going to end up with 2.7 times 10 to the negative third newtons times 0.52 squared equals 9 times 10 to the ninth. I'm going to, for time's sake and for space, I'm going to leave out those units, times Q squared. Okay, but I still want to find my Q value. So again, I'm isolating the Q. So I'm going to go ahead, before I do any calculator math, I'm going to go ahead and just set it up. I want this by itself. It means I have to get rid of every other term that's present. I'm multiplying here. I'm going to do the opposite operation. So that means I'm going to divide by 10, 9 times 10 to the ninth. What I do to the right-hand side, I have to do to the left-hand side. So I'm going to divide this side by 9 times 10 to the ninth. So then I see over here that falls out. So now I have 2.7 times 10 to the negative 3 newtons times 0.52 meters squared divided by 9 times 10 to the ninth equals Q squared. Okay, so let's go ahead and do that math, and then we'll solve the remaining part. Okay, so we have 2.7 times 10 to the negative third. Again, don't forget your parentheses around your terms. Again, just it makes it a little tidier. Divided by 9 times 10 to the ninth. Okay, so you get some number value, and now we can go ahead and write that number down. So make sure you have that correct. 2.7 times 10 to the negative third times 0.52 squared divided by 9 times 10 to the ninth. And you should get something like 8.1, we'll call it 8.1 times 10 to the negative 14th. And we won't worry about the units quite yet. but that equals q squared. And then the final step, of course, would be to take the square root. Okay, so I'm going to take the square root of both sides. Why am I doing that? Because I want to know just the value of q. So I can take the square root of my number value. And that's a number with lots of zeros. So you can hit the scientific notation button, count what I want your number to look like is in scientific notation. So make sure you have that in scientific notation. And to do that, there's several ways you can count the zeros if you want to. Or on your calculator button, there is a way to put it into scientific notation. If you don't know how to do that, then I can help figure that out tomorrow when I'm back in class. So you should get a Q value equal to 2.8 times 10 to the -7th. Again, if you don't know how to change your calculator into scientific notation, then just count the zeros and you should find that this would be your correct answer. Now, if we wanted to briefly look at the unit and figure out why it is this unit, then we would have to look at this would be meters squared, and this would be newtons times meters squared over Coulomb squared. So notice then that my newtons cancel out, my meters squared cancel out, and that leaves coulombs in the denominator of a denominator. And then we took the square root, so we would end up with that coulombs as our final answer. Okay, so there's two more that I want you to try on your own. There are answers available to you. Just ask the teacher. And then you have a handout today that's conceptual on the front, math on the back. Depending on how much time is left in class, I want you to have the conceptual questions complete when you come to class on Tuesday. And then we'll work some more of the math problems together. Or I will check them at least. Well, I'll give you some time on Tuesday to do those math questions in class. But for now, you need to finish the practice problems on your sheet, and then you'll receive the practice sheet that you have that is your assignment for today. Homework for tonight is to do the conceptual side only. Okay?